Okay, let's go through the paper. So we've got the paper here. Okay, question 1 says write down all the common factors of 16 and 20. So remember, it's talking about factors and not multiples. So some of you started listing down the 16 times table and the 20 times table. Be careful, it's talking about factors. So factors of 16 are 1 and 16, 2 times 8, 2 and 8, and 4 times 4, so 4. And then the factors of 20 are 1 times 20, 2 times 10, and 4 times 5. And so the ones that are common to both are 1, 2, and 4. And that's your answer. So they're the common factors of 16 and 20. Now for finding the area of this shape. We've got, so we're going to split it up. It's up to you how you split it up, but I'm going to split it up this way. I will find the area of this bit first. So it's 3 times 2, so 3 times 2 gives me 6 centimetres squared. And now I need to find the area of this bit here. I know that it's 6 plus 2, so 8 long. And then here, I know that all of it is 10, but up to this part is 3, so it's 10, take away 3, so it must be 7. So that means that the area of that bit is 8 times 7, which is 56 centimetres squared. I add them together to find the total, and it's 62 centimetres squared is the is the area of this shape. Be careful as you go through the school, especially when you get to your GCSEs. Sometimes you lose marks if you do not put the units. So I was quite lenient with marking your exams, but in future, make sure you put whether it's centimetres squared or centimetres or whatever the units are. You must put units. Okay, here the first term of a sequence is 11. The term to term rule is subtract 4. What is the fifth term of the sequence? So each time you have to take away 4. 11 take away 4 is 7. So that's the second term. 7 take away 4 is 3. So that's the next one. And 3 take away 4 is minus 1. And then finally the fifth term, which is what we want, minus 1 take away 4 is minus 5. Okay, so the answer is minus 5. Right, a different sequence has the nth term 3n take away 7. Find the first 4 terms of this sequence. Remember I said to you that the 3n means it's got something to do with the 3 times table. So you write the 3 times table down, which is 3, 6, 9, 12. And we only want the first 4, so I'm going to stop there. So 3, 6, 9, 12. And then you look at this second part. It's telling you to take away 7 from each of the 3 times table. So I'm going to take away 7 from each of these, and that will give me my final answer. So 3 take away 7 is minus 4. That's the first one. 6 take away 7, minus 1. 9 take away 7 is 2. And 12 take away 7 is 5. To be honest, once you get the first one, once you get 3 take away 7, which is minus 4, you can then, instead of doing 6 take away 7, 9 take away 7, 12 take away 7, you can just add 3, add 3 each time because it's 3n. So you could have done it that way as well. But the answer is minus 4, minus 1, 2, 5. So a boy writes the sequence with the nth term A10 take away 1. His sister writes the sequence that begins 4, 13, 22, 31 What is the first 3-digit number that will be in both of their sequences? This one's a little bit mean because I think the only way for you guys to get it is to actually write down the sequences until you get to a 3-digit number that matches up. So let's do it. So 8 times table, take away 1. So it's going to start with 8, take away 1, which is 7. And each time I'm adding 8. So I'm just going to write down 7, 15, 23, 31, 39, 47, 55, 63. And obviously it can be a bit worrying, especially if you go wrong somewhere. So hopefully I don't go wrong here. 71, 79, 87, 95, 103. I'll do one more just in case. 111. All right. Now let's do this sequence here, the sister sequence, which you can see is going up in 9. So each time it's going up by 9. So we've got 4, we've got 13, 22, 31, add 9, 40, 49, 58, 67, 76, 85, 94. Oh, and aren't we lucky? 103. So 103 is our answer. That's the first 3-digit number that will be in both their sequences. I gave 1 mark because some of you found 31, but be careful, that's a 2-digit number. So 103 is the answer you're looking for. Okay, express 210 as a product of its prime factors. So that's where we have the tree, so 210. Then 21 times 10. 5 times 2 is 10. These are both prime numbers, so I circle them. And again here, 3 times 7 is 21, and 3 and 7 are prime numbers, so I circle them. Now that gets you 1 mark. You have to be careful. Remember I told you, you have to write your final answer. 210 equals 2 times 3 times 5 times 7. You do not have to write it in numerical order. I just like doing that. But as long as you write it, the multiplication down. Okay, what is the highest common factor of 18 and 30? Lots of different ways. You can list all the factors of 18 and of 30 and then pick the highest one, or you can do your trees again. So 18 is 6 times 3, then 2 times 3. 30 is 6 times 5, and then 2 times 3. Draw your Venn diagram. And there's a 3 that appears on both, a 2 that appears on both, so that goes in the middle. And then on the 18, I just have the 3, and on the 30, I just have the 5 here. To be honest, it doesn't matter. The rest of it, all that matters is what's in the middle. So the HCF, in this case, is 3 times 2, which equals 6. So the highest common factor is 6. But you would have got that as well if you had listed the common factors of 18 and 30. Okay, here it says which number is a factor of 90 and a multiple of 6. To be honest, factors of 90, I'll just highlight them. So you know 9 is, 45 is, and I want to say that 18 is, yes. 36 is the only one that is not a factor of 90. So it's not, it doesn't go into 90 without a remainder. So then you have to look and say, okay, which one of these is also a multiple of 6? This one, so this one is not a multiple of 6. Is not, 9 does not appear in the 6 times table. 45 does not appear in the 6 times table, but 18 does. So your answer is 18. So 18 is both a factor of 90 and a multiple of 6. Right, next one, the area of a square is 144 centimetres squared. You need to know your times tables for this. Basically, if it's a square, it means that both sides are the same. So you have to think to yourself, what number multiplied by itself will give you 144 centimetres squared? The only one is 12 times 12. So each of the sides must be 12 for it to have an area of 144 centimetres squared. So then perimeter, you add up all the sides. So we're going to do 12 plus 12 plus 12 plus 12, which is 48 centimetres. And remember what I said about writing units down. Right, another product of prime factors. So 180, so 18 times 10. 5 times 2, circle the 5 and 2 because they're prime. 6 times 3, circle the 3 because it's prime. And then I'm going into another question here, but 2 times 3 here. And remember I said to you that just gets you 1 mark. To get the full marks, you need to write down your answer. 180 equals 2 times 2 times 3 times 3 times 5. Okay. The reason why you have to write it as your answer is so that you understand it's a product of its prime factors, so that you're multiplying all the prime factors together. Okay. Nth term of these numbers. Let's do this before I run out of battery. No, it'll be fine. It's going up in 8s, as you can see here. So it's going up in 8. So that you know it has something to do with the 8 times table. So you write 8n. That got you at least 1 mark. So that got you 1 mark as long as you understood it was 8n. Write the 8 times table on top. 8, 16, 24, 32, 40. What am I doing to these numbers on the top, so the 8 times table, to get the numbers underneath? Each time I am adding, each time I'm adding 1. Adding 1 each time. So our final answer is 8n plus 1. Right. Next question, again, you need to, I almost fell into the trap a lot of you fell into. I was going to say split up the shape, but no, this is asking for perimeter. So be careful, it's asking for the perimeter, and I almost just now found the area. So be careful, and a lot of you did this, a lot of you found both, weirdly. So we want to find the perimeter. So we're going to add up all the lengths, okay? So we'll start with this one, 8. So I'm going to do 8 plus the 12 plus, now we need this side here. It must be the same as this one, so it is also 8. So we're going to add the 8 as well. Then we are going to add 3. So I'm just going round the shape. Then I need this length here, which is the same as this length. So it must be 4. So I'm going to add 4. Then I need this length here. I know all of it is 12. So then I need to take away the 3 here and the 3 here. So I need to take away 6. So this must be 6. So I'm going to add on 6. I'm going to add on the 4. And then finally, I'm going to add on the 3. And the reason why I've gone around highlighting, or you could have just ticked, is to make sure that I've got every single side with a shape like this. It's much better to make sure you've got all sides. What I tend to do when I'm adding, just to make sure, is I try to bunch them into 10s and 20s. So 8 plus 12 is 20, plus 6 plus 4, so that's 30, plus 3, 4 and 3, which is 40, and so altogether it is 48. And remember your units, so 48 centimetres. What are the first 5 triangular numbers? We went through this the day before, but I realised that some of you didn't quite pick up on that, or didn't quite listen, but it's here. So it's these. Yeah, remember I showed you that the reason why they're called triangular numbers is because they look like triangles. You can make triangles with those. So 1, 3, 6, 10, 15. What is the nth term for the following sequence? These are your square numbers, so it was only worth 1 mark. Your square numbers n squared, so that's the nth term for your square numbers, n squared. Okay, lowest common multiple for these numbers. Again, you could go right down the 36 times table and the 120 times table and see where they match up. Or you could do your trees. I always prefer trees, so I'm going to do mine, circling my my prime numbers. Do the same here for 120, and circling my prime numbers, which I think some of you forgot what your prime numbers were. So some of you need to get better at just your revision. Okay. Draw my circles for my Venn diagram. 36, 120. So I've got a 2 that appears in both. Another 2 that appears in both. A 3 that appears in both. And I think that's it. So what's left for 36 is a 3 here. What's left for 120 is a 5 and a 2. Okay. Now remember, the lowest common multiple, you multiply all the numbers in the Venn diagram, not just the middle this time. So to find the LCM, we're going to multiply 3 times 2 times 2 times 3 times 5 times 2. So I'm going to multiply all of it, and that gives me 360. Okay, so the LCM is 360, and you would have got the same if you had written the 36 times table and the 120 times table. And again, for part B, you could do the 5 times table, the 12 times table, and the 16 times table, and see which one appears in, what's the lowest number that appears in both. But again, as I said, I like the trees, so I'm going to do them. So I've got 5, I've got 12, like this. I've got 16. Oops. And then this is the bit I think some of you don't like, is that because there are 3 numbers, we have got to, when we're doing our Venn diagram, we have to draw 3 interlocking circles like so. Okay. Although I don't think there's any that actually match up for all 3. So there's nothing that's going in this middle here. 5, there's 12, and there's 16. Let's fill it in. So we do have a 2 that appears in 12 and 16. Another 2 that appears in 12 and 16. And then there's no other ones that match up. Just a 5 here, 3 here, and then a 2 and a 2. And then, as I said to you, the LCM is all the numbers multiplied together. So 2 times 2 times 2 times 2 times 3 times 5. Okay, and that is 5 times 3 is 15. Double it, 30, 60, 120, 240. So 240. Next, what is the missing number? So it subtracts 6 each time. So we've taken away 6 each time. And 48 take away 6 would give you 42. So that's the missing number. What's the area of this triangle? 3 times 8. Do not forget to half it. So 3 times 8 is 24. Divided by 2 gives you 12. Do not forget your units, so you remember to put centimetres squared, so 12 centimetres squared. Last 2 questions. A triangle fits inside a square of area 64 centimetres squared. Remember that a square, you're looking for 2 numbers that multiply by itself to make 64 because the lengths have to be equal. And the only one is 8, so 8 times 8 is 64. So it means that this triangle that's fitted in here has a base of 8 and a perpendicular height of 8 as well. So the area is 8 times 8, and don't forget to half it. 8 times 8 is 64, half of it is 32. And don't forget your units, so centimetres squared. Right, so 8. And then last question, which was there to challenge you and to pick out the kind of top students, but I was glad to see that the majority of you tried this. Find the area of the parallelogram first, because it says that the areas are the same. So remember, it's base times perpendicular height, so 4 times 7, so it's 28 metres squared, the area for the parallelogram. Now, we know that this area must be the same. We know that if we do b plus 3 and we halve it and then times by 5, it will give us 28. Now, to find b, you undo all of that. You basically go backwards. It doesn't matter really what order you go in, but I'll undo the times by 5 first and divide by 5. So I'm going to do 28 divided by 5 using my bus stop. How many 5s go into 0? How many 5s go into 28? 5. Remainder 3, so I put a point and a 0. And how many 5s go into 36? So I know that b plus 3 divided by 2 equals 5.6 because I've divided by 5. Next, I'm going to double it to get rid of the divide by 2. So I'm going to times by 2. And 5.6 times by 2 is 11.2. So b plus 3 equals 11.2. Then I'm finally going to undo the plus 3 by taking away 3. That gives me 11.2 take away 3 is 8.2. So b must be 8.2. Okay, well done.